Hi everyone, welcome back to my number sense series. In this video we're going to talk about exponents for the first time, but not just regular exponents, fractional exponents. Things like number sense likes to ask you, 125 to the power of 4 over 3. What's 243 to the power of 1.2? What does raising something to the power of a fraction even mean? I mean, as we understand it, exponentiation is when you multiply a number by itself. 5 times 5 is 2 5s multiplied together, that's 5 to the power of 2. 6 to the power of 3, 6 3's all multiplied together. So how can you have like half a number or something? Well, this might be new to some of you and it might not be new to some others, but there is a place that we have actually already seen fractional exponents. The square root. For example, the square root of 16 equals 4. But a square root is an exponent, and it's actually saying 16 to the power of 0.5 equals 4, or 16 to the power of 1/2 equals 4. A square root is something raised to the power of 1/2. And so here we get kind of an idea for what a fraction might be, or at least fractions like 1/2, 1/3, and 1/4. Because if 16 to the power of 1/2 is a square root, then what's 16 to the power of maybe 1/3? Well, you might guess that it would be a cube root, and that's exactly correct. So that would be the cube root of 16, which is not simplified to a nice number, but that's besides the point. The point is that any number to the power of 1 over n is like the nth root of that number. Now, let's recall something else. What if we wanted to do like 8 to the power of 1/2? In other words, the square root of 8. It's also the square root of 2/3. And so recall that a square root is, of course, raising something to the power of 1/2. So this is like 2 to the power of 3 to the power of 1/2. And when you have something raised to a power, and then that whole thing raised to another power, what you can do is actually just multiply the exponents. So this is equal to 2 to the power of 3 over 2. And this is where the important relationship comes in. You can see that 2 to the power of 3 over 2 is the 2th root, kind of the second root, of 2 to the power of 3. In other words, a number to the power of like a over b is going to be the bth root of that number to the power of a. So here, this is going to be the cube root of 125 to the power of 4, or the 4th root of 125 to the power of 3. You can think of it either way. So, of course, it's better to work with small numbers. So let's take a cube root first. And this is what we're trying to calculate. The cube root of 125 to the power of 4. The cube root of 125 is 5, so what's 5 to the power of 4? Well, that's 25 squared, which is 625. And that would be our answer. And here's another slightly different way of thinking about it. If we recognize 125 right off the bat, which hopefully you should, as 5 to the power of 3, then this would be 5 to the power of 3 to the power of 4/3. And remember once again that we can multiply our exponents 3 times 4/3, which also just give us 5 to the power of 4, which is 625. So all roads lead to Rome. Everything leads to the same answer in math. But this is how a fractional exponent would work. So let's try another example. For example, 243 to the power of 1.2. This might not look like a fractional exponent, where's the fraction bar, but remember, of course, that decimals are just exponents, and so we should be able to recognize 1.2 as a fraction known as 6 over 5. So this is 243 to the power of 6 over 5. So it would be the 5th root of 243 raised to the power of 6. And now the 5th root of 243. Now this is kind of like a weird problem. Who memorizes 5th roots? But if you think about it, it can't be a big number at all. Multiplying a number by itself 5 times, if that number is anything that's not a small number, it's going to shoot up super, super fast. So if you just think about it for a second, it can't be 2, it's probably not 4, it's probably 3. And if this is a little bit too hand-wavy for you, you should memorize your exponents. I would recommend memorizing up to maybe 2 to the power of 10, and then 3 to the power of 6, because this would allow you to recognize that this is actually 3 to the power of 5. And so this would be equal to 3 to the power of 6. Now 3 to the power of 6, there's a few ways of doing this. You could think of 3 to the power of 6 as 9 cubed, or you could think of it as 27 squared. So depending on if you've memorized your cubes or your squares more fluently, either way, this would give you an answer of 729. Now, the next question is going to be pretty similar, and this time they do tell you that it is straight up a fraction. 64 to the power of 7 over 6. So, same drill. This is going to be equal to the 6th root of 64 to the power of 7. Now, the 6th root of 64, once again, if you memorize your exponents, this is going to be really, really easy because the 6th root of 64 is just 2. Remember, they will almost never give you a root that is not an integer. Maybe they'll try to sneak in something sneaky like the square root of 1.21, but that's also able to be figured out. So the 6th root of 64 is 2. So our question is asking what's 2 to the power of 7, and hopefully you have done as I recommended, or after watching this video you will, because I really, really recommend it. Memorize your powers. 2 to the power of 7 is 128. Okay, next question. 343 to the power of 4/3. Once again, this is going to be a question that is dependent on you having memorized your exponents. So once again, super important and just honestly really helpful to know. 343 to the power of 1/3 first. Let's ask, what's the cube root of 343? The cube root of 343 is 7. So, if you are struggling to figure this out in contest, you can always think back to our cube root thing where we listed out all the last digits of, cube roots. So for example, if you cube something ending in 2, your answer is going to end in 8. If you cube something ending in 3, your answer is going to end in 7. And it's a 1-to-1 mapping. So if the cube of something ends in 3, then you know the original number must have ended in 7. 7 is the only number that when you cube it, the unit digit maps to 3. So you know that it has to end in 7, and of course it's going to be a small number, so the only answer is just 7. Now we ask, what is 7 to the power of 4? 4. 7 to the power of 4. Now this is not a number that most people would memorize, because I know a lot of people who have 7 squared and 7 cubed memorized, but not a lot of people who have 7 to the power of 4 memorized. And kind of makes sense, because this is when you get into the thousands. But 7 to the power of 4, if you think of it as 7 squared, this is just equal to 49 squared. And maybe you remember that trick we talked about a long time ago about squaring any number from 40 to 60. In that video, we talked about find out the distance of this number to 50. The distance of 49 to 50 is 1. And now it's less than 50, so our answer is going to be 25 minus 1, because it's the distance of 1, so it's 24 as our first 2 digits, then 1 squared as our last 2 digits, 2401. Pretty nice to memorize, and I think pretty cool number, 2401. So last question, this is definitely the hardest, because it is the only one that involves a negative exponent. But don't panic, negative exponents still work as they did before. And if you don't remember what a negative exponent means, let me just refresh your memory. Something to the power of a negative number. For example, 6 to the power of negative 7, that's just 1 over 6 to the power of 7. In other words, get rid of the negative sign and put it 1 over. So this is going to be 1 over 0.25 to the power of 0.5. And now what is the meaning of something to the power of 0.5 again? It is just a square root. So it's asking what's 1 over the square root of 0.25. Now maybe you recognize this immediately, or maybe you don't. But if you don't recognize it immediately, you can think of it as this. 0.25 is 1 over 4. Now the square root of 1 over 4, that's the square root of 1 over the square root of 4, which is 1/2. So it's 1 over 1/2, which is, of course, 2. Or you could just recognize this as 0.5 squared, so it would be 1 over 0.5. How many halves are in a 1? 2. So the answer is going to be 2. So that is fractional exponents. I think the biggest roadblock to understanding fractional exponents is really just knowing what they mean, because once you understand what a fractional exponent actually is, then the computation is very easy as long as you've memorized your exponents. Now, if you haven't memorized your exponents up to the expected degree that they would test in contest, for example, if you only know 7 to the power of 3 and not 7 to the power of 4, or if you only know 2 to the power of 6 and not 2 to the power of 7, it's okay because you can still figure it out in contest. But if you've memorized it, it's going to save you that little bit of time in contest. That could be, 1 or 2 extra questions. That's a leaderboard spot. So really, just memorize your exponents, understand what a fractional exponent is, and this is going to be really, really easy for you guys. So thank you guys so much for watching, and I'll see you in the next video.